Today we're going to review the distance formula, which is just a form of the Pythagorean theorem. And so we're going to treat it, to start at least, the same way we do for midpoint and slope, by identifying your first two ordered pairs, your x1, y1, and your x2, y2, and we'll label them as such. So when I see that first point over here, we're just going to count to the left 5, so -5, and then up 3. So I've got an ordered pair here at -5, 3. And I'll label both of those coordinates as my x1, y1. And then down here, we've got 8 units to the right and 2 units down. And so that second ordered pair is at 8, -2. So my x2, y2 are 8 and -2. So once we've labeled both of those ordered pairs, these are directions for midpoint, so we're going to work actually with the distance formula here. So let's go ahead and fill in those, let's go ahead and fill in those variables into that formula. So we're going to start with D for distance is equal to. Now, the last thing you're going to do is take the square root, so we'll just continue that through as we write this formula out. It's parentheses x1 minus y1. It's the distance between those two x coordinates. So from -5 to +8, it's -5 minus +8, and then we square that distance. We'll add that then to the distance, our y1 minus y2, between our y coordinates. So 3 minus -2. And again, we square that. And then that's the square root of all of it. Now, reminder, the square root is the last thing we're going to do. So let's take care of everything underneath that radical first. We'll start with what's inside those parentheses. Reminder, order of operations is groups first. Then we'll take care of exponents, any multiplication, division, and then any subtraction or addition. All right? So -5 minus 8 is -13. We'll square that. Plus 3 minus -2 is 5. And again, we will square that number. Don't forget, the distance formula is the square root of all of that. Eventually, we'll take the square root of all of it. Now, be sure that if you're going to put this into Desmos, you've got parentheses around your negative here. -13 times -13 is 169, plus 5 times 5 is 25, and we will take the square root of this. Square root is the last thing we do, you guys. 169 plus 169 plus 25 is 96. Let's add those up. $169 plus 25 is 194. 194. All right, now 194 is actually not a perfect square, so what we're going to do is put that into Desmos. We're going to ask for the square root of 194, square root right here, 194, and we get 13 point, let's round to that first decimal place, is 9, 13.9. So the distance then between these 2 points is 13.9, The distance between the first point and the second point, 13.9 units. Now, we're not going to show that switching labels doesn't make a difference, but it doesn't. If I call this point my x2, y2, and this my x1, y1, we're still going to get the same distance. That won't change. Now, what we are going to do is show that the Pythagorean theorem works exactly the same way. What you want to do is remember that the Pythagorean theorem, I prefer it a squared plus b squared equals c squared. That's usually how it's presented to us. A squared plus b squared equals c squared, where c is the hypotenuse of the right triangle, and a and b are the legs. Now, what we need to do then is to form a right triangle with the 2 points that we were given. So we're going to draw a line from here to here, and then across over to the second point. And then when I connect those 2 points with the diagonal line, that's the straight line distance between them. That's the 13.9. We need to figure that out based on the length of the legs. And again, order of the ordered pairs doesn't make a difference. So when I think about switching labels, when I think about which side is A, which side is B, that part is irrelevant. So if I make this part A squared, you can count. All right, you can count from 3, 2, 1, 0, -1, -2, or you can see that the distance between Positive 3 and negative 2 on that y-axis is 5 units. Same thing happening along the horizontal leg of the triangle over here. From negative 5 on the left over to positive 8 on the right. You can count, you can figure out the difference or the distance. Either way, we're going to get 13 units here, okay? And then that's my 5 squared plus my 13 squared is equal to c squared, all right? 5 squared is 25. 13 squared is 169. That is equal to c squared. We can see that all these numbers are exactly what we had using the distance formula. It's just a little less cumbersome here. 25 plus 169 is that 194. That's equal to c squared. And then in order to undo the square, we take the square root. All right, so we're going to do that on both sides. The square root of 194 is equal to the square root of c squared. Squares and square roots undo each other, and we're left with just c, which is the hypotenuse, which is the distance, is 13.9, the square root of that 134. So whether you use the distance formula or the Pythagorean theorem, we'll get the same value, which is the distance between the 2 points given, okay? So as you continue along with page 15 and 16, all right, I want you to use the distance formula and the Pythagorean theorem to show that you're getting the same distance between the two. Don't forget to start by identifying the ordered pairs and then labeling them as your x1, y1, your x2, y2. And then for distance formula, you're going to plug everything into that distance formula, right? X1 minus x2 squared plus y1 minus y2 squared, and we'll take the square root of all of that. Pythagorean theorem reminder, we're going a squared plus b squared equals c squared, where a is the vertical distance, b is the horizontal distance, and c is the hypotenuse, is the straight line distance between the 2 points. That is the hypotenuse of the right triangle. So if I put that over here for you if you like the color coding, and that's going to help you. Again, with Pythagorean theorem, you're solving, at least in this situation, for the hypotenuse.